Okay, good morning, students. Okay, so here every day we are doing one lessons. Okay, last class we studied about solid state, no? Okay, so today we are going to see one lessons in organic chemistry. This also a 12th portion. So the chapter is what? Alcohols, phenols, and ethers. Okay, so mostly uh, organic chemistry means you must thorough all the important reactions as well as name reactions, especially name reactions. You must be thorough all the name reactions. Okay, then trend, based on trend they will ask some question. Trend means boiling point trend, okay, nucleophilic substitution trend, likewise, okay, acidity trend, okay. So this kind of questions we can expect in this lesson. Okay, then most important one is they will give the reactant, we have to find out the product. They will give A, B, C like that. Okay, right hand side they won't give the product, instead of B product they will give out only A, B like that. So what is A, what is B, we have to find out. So that kind of questions we can expect mostly in organic chemistry. Understood? Okay. So all the 4 lessons are very important. So thorough all the 4 lessons, alloylene, allurin, this is the second chapter, then amines, then aldehydes, ketones, that lesson. Understood? So all the 4 lessons are very important. Study 2 or 3 times, not only one time. Okay. So first study the concept, I am telling always. First study the concept, then go through the MCQ, then it will be easy. Okay. Study 2 or 3 times, not only one time. You should be, you are all getting fingertips, that guide, no. But the answer should be in fingertips, that is very important. Okay. So especially the name reaction. Okay, if I give one reaction means you must know this is the name of the reaction, this is Dow's process, this is Williamson ether synthesis, you must know. Then only this any questions coming from organic chemistry will be easy. Understood? Okay, right. You have 3 topics in this lesson. Okay. Okay. Now I'm going to start alcohols. The formula is ROH. Formula is what? ROH. You know that. Okay. So this is all IPS name. This is all I think. R means instead of R we can put what? Methyl. Instead of R you put what? Ethyl. Understood? This is all Instead of R you put propyl group. This is all Understood? Methanol. Ethanol. When you come to third carbon atom, give the number 1, 2, 3. When you come to third carbon, you give the number. So propan, 1 all. This is all Understood? Suppose here, the most important one is number. Suppose here, so here double bond is also present, OH is also present. So give importance to OH group. Which carbon OH is attached? That's the first carbon. Understood? Okay. Then, so it's the first carbon, no? 1, 2, 3. Understood? Here, 3 carbon, no? 3 carbon means what? Propan. Okay. 1 all. 2 in 1 all. Okay. Can you say like this? Double bond in between 2 and 3, no? So, 2 in 1 all like that. Okay. Understood? So, give importance to alcohol group. Understood? Okay. So, this is all IPS name, Okay, now we are going to study directly how the alcohol is prepared, what are the important properties behind. Okay, likewise, each and every one we should know. Phenols preparation properties, ethers preparation properties. Okay, this only I am giving, just note down one by one. All the reactions you must know, then only it will be easy. Okay, you just copy them, this only, be quick. So keep on writing, listening, writing should be going on simultaneously. Then only we can complete the portions. Even at least 1 minute, don't waste. Okay. You just go through, all the, just know, 1 to 10 carbons, you just keep in mind, methane, ethane, propane, butane, pentane, okay, hexane, heptane, octane, nonane, decane. Okay, so keep in mind. So this one is just, if you have double bond and no, priority order is given in 11th standard, priority order. Which one you have to give more priority means alcohol group. Then only double bond, then only triple bond goes on. So OH only give here, understood? 1. This carbon OH is attachment is a 1, is a 2, 3, like that. Okay? Right. Sometimes here, this is all 2 times is there, what is this? Diol, no? Understood? So 1, 2. Ethane, 1, 2, diol. Understood? Then, suppose 3 OH group means what? Triol. Understood? 3 OH means called triol. So here give the number. Give the number 1, 2, 3. Understood? 1, 2, 3. Propane. There are 3 carbon, no? So what? Propane, 1, 2, 3, triol. Okay? Understood? Just write fast. Okay. Finish? This is all Okay, you studied in lower classes. Okay, now let us go to the preparations of alcohols. Understood? Okay. Okay, see here, you put the heading, preparations of alcohols. Preparations of alcohols. Okay, we have 4 methods. One is, see that, from alkene. From alkene we can get. From alkene means I am taking this one, propene I am taking. Okay, because any Marconic rule undergoes means you must have at least 3 carbon. 2 carbons, Marconic rule will not undergo. So you take propene. Then acid hydrolysis, you know that when we add water, what happens? The water out split, H plus, OH minus. So this is added according to what rule? Marconic rule, no? Understood? So negative part goes to carbon atom which carries less number of negative part goes to carbon atom which carries less number of hydrogen. Okay, we are adding like this. Minus goes here, plus part. Following. Okay, so product will be CH3CH OH. Following. Okay, so this is one from alkene we can get alcohol. Understood? So here this is name, what is this? Propan 2-ol. You following? Okay. Write fast. What rule began here? Marconic rule. Marconic rule began. Okay. Write fast. You have on pencil. Okay. So this arrow mark, this dotted lines, this is all used by pencil. It will be easy. Okay. Understood? Next one also from alkene, but here we are following anti-Marconic rule. That only is called what? Hydroboration method. Hydroboration, oxidation. They'll give like this. This also from alkene, but the same alkene I am taking, propene. Okay. Here, anti-Marconic rule only identify means we should put what? Any peroxide. Peroxide is there means it's an anti-Marconic rule. So peroxide, they'll give the question like this: H2O2. Okay. H2O2 in place of basic medium. Then we are using diborane. That's what's called hydroboration method. Okay. So they'll give question mark. You have to find the product like this. So if you see this one means you must remember what is this? Anti-Markovnikov rule. Just remember, you don't worry about this one. This reagent only just memorize. If you see this reagent means you must know water is added in presence of in the followed by what? Anti-Markovnikov rule. Understood? Same thing. Same. This water how to split? H plus OH minus. Okay. If you see this reagent, you must remember water is added following what? Which rule? Anti-Markovnikov rule. That's all. Okay. This only you just remember. AM I put simply. Okay. Then after that you know that, last time negative part goes, no? Now this time what? Positive part goes. That's the difference. Okay, right. Then you know the product. What's the name of the product? What's the name of the product? H goes here and it becomes CH2. So CH3, CH2. Anything coming means double bond becomes single bond, So CH2, OH. Propan, 1 all. Understood? Right, right fast. Same propene, if you use this reagent, we are getting propan 2 all. Same propene, if you use this reagent, we are getting propan 1 all. Okay. So reagent is differ, product also differ. Okay. They'll give the reactant, they'll give this reagent, right hand side question mark. So they'll ask like this mostly, or they'll give reactant and product they'll give. The reagent they'll ask, reagent. Okay. Or they'll give everything, reactant, product, everything. What's the name of the reaction? Okay. So anyway, they'll ask in different reactant, product, reagent, name of the reaction, okay, whatever it may be. So you study thoroughly, you can able to, then only you can able to get the answers correctly. Okay. Finished the 2 equations? Okay. The second method. Okay. Then third method. From carbonyl compounds, Third method you put the heading from reduction of carbonyl compounds. What is carbonyl compounds? What is carbonyl compounds? It may be aldehyde or ketone or acids. Third method is from carbonyl compounds. From reduction of, just write, reduction of carbonyl compounds. Understood? Carbonyl means compounds having what? C double bond O group. Okay, any compounds having C double bond O group, that compound is called what? Carbonyl compounds. Understood? It may be aldehyde or ketones. Mostly aldehyde. If I take aldehyde means what's the formula for aldehyde? It may be RCHO or it may be RC double bond O. Understood? This is aldehyde. This is called what? Ketone. Understood? Okay. RCHO or RC double bond O R dash. Understood? Okay, right. See here, I am taking directly one example. Instead of, first I am taking R, instead of R I put what? CS3. For convenience I am writing like this. CHO means you must know, it's aldehyde. Okay. Reduction, what is reduction? Addition of hydrogen. So in process of, we can use any palladium as a catalyst. So what happened? Cut off. H. So CH3, CH2, OH. Understood or not? CH3, product will be CH3, CH2, OH. Just listen, then you write. I'll complete this one. Then you can take any aldehyde. Aldehyde is reduced by this reagent. Okay. We can get alcohol. It's called ethanol, no? Correct or not? Ethanol. Aldehyde ends with AL. Ethanol. This is called what? Phenol, OL. Are you following? Okay. So I'm saying I'm taking aldehyde, or we can take from ketones. Ketone also we can take. Ketone means what's the formula? R C double bond O R dash. Instead of R we put CH3. Understood? What's the name of the compound? It's also reduced by mostly sodium borohydride. Sodium borohydride, or sometimes mostly sodium borohydride is used, but sodium borohydride only is a strong reducing agent. Sometimes we can use lithium aluminum hydride. Okay.
Strongest reducing agent lithium aluminum.
Both are there, but lithium is very costly one. Then only they are using sodium borohydride. That also we can use. Okay. Anyone? Mostly in case of if you want to reduce all ketones, mostly we can use this one. Sometimes in this place also they are using. Sometimes. Okay. Availability. Then this is somewhat cheap when compared to lithium aluminum hydride. Okay. So what happened? This also supply HH, no? Can you put like this? Understand? Product CH3CH OH CH3. Understand? Correct or not? CH3 CH OH. Okay. This is called what? Propane to all. Understood? Right fast. Understood? The agent, what's the role of this reagent you must know. Okay, this is a reducing agent, you must know. Okay. Okay. Sometimes we are getting this, this alcohol is getting from only acids also sometimes we are getting. Okay. So, but this is the most important method, these two, from aldehyde and ketones. Understood? Then fourth one is so they will give the compounds like this. See, listen. What's the product? It's called cyclohexanone. No? Cyclohexanone. It's what? It's a reducing agent. That will supply what? Hydrogen, H2. So what happened? Here you put HH. Understood? Okay. So already C is there. Now CH, single bond OH. Okay. The product will be what? Cyclohexanol. Cyclohexanone becomes cyclohexanol. Understood? Okay. So last like this. So C double bond O becomes CHOH. Okay. Right. Then fourth method. Just note down this also. Everything right. All the four methods are important. Okay. Next one, the fourth method is from Grignard reagents. What is Grignard reagents? R, this is a formula. Okay, R MGX, it's a formula. You know that. Understand? Here, just before study this, you just remember this one. If you put, GR, Grignard reagents plus HCHO, we get primary alcohol. Just write. Short form first of all you write. Grignard reagents plus, it's called HCHO means formaldehyde. CH3CHO means what? Ethanol, acetaldehyde. We get secondary alcohol. Then Grignard reagents plus, ketone. Any ketone we can take, especially propanone I am taking. Then we are getting what? Tertiary alcohol. Okay. Just write. This is very important. Keep in mind. If you know this means, Nothing. For getting tertiary alcohol, Grignard reagent reacts with dash. They will ask any ketone. For getting secondary alcohol, Grignard reagents reacts with dash. Okay. So this one is just keep in mind. First two are aldehyde. Next, the last one is called ketone. Okay. Understood? Are you following? Simple one. So I'll write only one equation. This only you just keep in mind. Okay. The question may be like this. For getting 2-methyl propanol. For getting 2-methyl propanol. Okay. Grignard reagents reacts with dash. It's a question. For getting 2-methyl propanol, Grignard reagents reacts with dash. What's the answer? Two-methyl propanol is what kind of alcohol? What kind of alcohol? Propan, no? Propan. 2-ol, no? OH. The same 2-ol, which one is present? CH3 is present. 2-methyl, no? Then you can fill by hydrogen. What kind of alcohol this is? Primary alcohol or secondary alcohol or tertiary alcohol? What happened? What is primary alcohol? Simply remember, CH2OH is there what? Primary alcohol. Secondary alcohol, CHOH is called what? If you have common having CHOH, it's called what? Secondary alcohol. What tertiary alcohol? COH. It's called tertiary alcohol. Understood? What is this? What is this? COH. Just remember. CH2OH, CHOH, CH. Understood? COH. It's called what? Tertiary alcohol. It is a tertiary alcohol. So I told you, for getting tertiary alcohol, Grignard reacts with what? Dash. It's a ketone, any ketone, mostly ketone. Okay. So sometimes the carbon number also increases. Okay. That kind of common you have to select here. Understood? Okay. Anyhow, mostly ketone. Okay. First two are only aldehydes. Understood? Okay. Just note down. Note down. Be quick. Examples. So I'll give you one equation for this. First you just write. This is a question. This is a question. You put question mark. You put Q. The question may be asked like this. Okay. Finished? So you just memorize this part. Okay, if you know this. Okay. So only one equation I will write. This is an all important one. First of all, you should know what is primary alcohol. CH2OH, primary CHOH, secondary COH is called tertiary. You must know. Okay. So here, finished? Okay. So I will give one equation. See, this first equation I will give. Remember, you can able to do easily. Grignard arrangements, what's the formula? RMG. Instead of R, I put what? CS3. Mg. X, instead of X, I put what? Br. Okay. SCHO, for our convenience, we can write like this. Can you write like this? You have to write C double bond O. Then, this is, C plus O minus. This is also minus, this is plus. Charge you must know. Okay. Then, after that, CS3 minus, CS3 minus, it goes to what? C plus. Is it correct or not? MgBr, no? It goes to O. Plus minus. That's all. Now the product will be, what's the product? H, C, H, top, CS3 will be the down, OMG, BR. Understood? Anyhow, if you add any Grignard reagents followed by hydrolysis, listen, look at the board. Whenever if you add Grignard reagents followed by hydrolysis, what happened? Here H, here OH. So the product will be CH3, CH2, OH. Correct or not? CH3, listen, look at the board. CH3, CH2, OH. Nothing but what kind of alcohol? This is what kind of alcohol? This is what? Primary alcohol. Understood? Okay. So I told you clearly, primary alcohol, if you want to get formaldehyde, we should take. This is called formaldehyde. Second alcohol, if you want to get, we should take what? Acetaldehyde. Acetaldehyde, nothing but ethanol. Methanol. Understood? This is called what? Methanol. This is called what? Ethanol. This is called what? Propanone. The basic compounds you must know. Then it will be easy, very easy one. Understood? Right fast. Other compounds you can try yourself. Same thing. H I know. Instead of H I put CH3 means we can get this one. Then this also, listen, here also the both the H is replaced by CH3 means we get this one. Okay. Both the hydrogen is replaced by what? CH3 group. So it goes on. Same process goes on. Okay, leave some space. You write this one, be quick. As usual. First you write this one, I'll explain. Understood? The one step, first one method of preparation you study thoroughly. Same method, say, I written this one. Okay. If you are a chemistry student means you must know this. What is primary alcohol? CH2OH, primary alcohol, CHOH, secondary alcohol, COH, tertiary alcohol. It's a simple way to memorize. Okay. If I give one definition means no one knows. Okay. So you write, you remember like this. Okay. It's highly enough. Okay. So second one, see the just write instead of H what? We put CS3 MGBR. Second one plus instead of H what? We put. Then as usual, the reaction going on. Same process. I told you, what is that? This is plus, C plus O minus always. This is minus, this is plus. After that, reaction going on. You do, leave some space, do later. Same method. Understood? This only just copy them. Do after that. Finished, huh? Okay, very good. So these are the methods to prepare alcohols. Okay. Fourth method, very, very important. Fourth method, second method, not second, third method. Third and fourth, put important sign. Finished? Okay. Next one is properties of alcohol. You know that properties of alcohol? Okay. Okay. just put the heading properties, chemical properties of alcohol. Okay, right. See, important one. So we have I think 4 or 5 important properties are there. Okay, first one, that esterification. What is esterification? To prepare ester, isn't it? Ester formula RCO or dash. Ester, how will you prepare ester means any ester, that any alcohol plus acid, we get what? Ester plus water in presence of any acid medium. This is a basic formula. Understood? Alcohol plus carboxylic acid. Then I simply put acid, but actually carboxylic acid in presence of acid medium to form ester. Understood? So that. Acid means first I'll write. Okay, first write acids. Any carboxylic acid we can take. I'll take simple acid. Acetic acid. Alcohol. Ethanol I am taking. Understood? In presence of acid medium, what happened? It's a dehydrating agent, no? It's a dehydrating agent that removes water molecule. So what happened? The product will be CH3 COO. Understood? CH3 COO CH2 CH3. Are you following? Okay. CH3 COO CH2 CH3 plus what? Ester. No, this it looks like ester. Here this group is called ethyl. 2 carbon. No. So what? Ethanoate. Ethyl ethanoate or ethyl acetate, we can say. Both are same. All acids ends with what? So ester ends with OATE. Ethanoate, methanoate, propanoate, like that. Understood? So CH3CH2 is called what I put ethyl. 2 carbon, no? Ethanoate. Understood? Just right. So first chemical properties. Write fast. What is the role of this reagent? This is called what? Dehydrating agent. Understood? Okay. That removes water molecule. That's why it's called dehydrating agent. Any acids, any aromatic acid also you can take. Aromatic acids, aromatic alcohol also you can take. But general principle is what? Any alcohol plus acids to get ester. Okay. Sometimes acid instead of acids, sometimes we can use what? Acyl halide. See, or you can write acyl halide. ACEYL. Acyl halide. Or we can use acetic anhydride. Acetic is also right. But alcohol is same. Acid we can take, or acyl halide we can take, or acetic anhydride we can take. Anything. This also just note down. Acid we can take, or acyl halide we can take. Okay. So this reaction, one reaction I will write. Ethanol is same, no? CH3, CH2, OH. Acyl halide means what's the formula? Acyl halide formula is what? Just remember all the formula, keep in mind. Then only it will be easy. RC double bond OX is the formula for acyl halide. Understood? RC double bond OX. Okay? Alcohol common. Okay, this reagent only differ. Okay, we have this, if you alcohol is common, we can use acid or acyl halide or acetic anhydride, any one among these three, we can get ester. Okay, acyl halide means, instead of R C double bond, no, instead of R I put CH3, then C double bond O, X may be what? Any halogens. Understood? Here, last time water is removed, no, we can use to remove. So we put on H plus, no. Here also, here mostly they are using one pyridine we can use. Okay, pyridine we can use in this case mostly. It's a pyridine is a base to remove what? HCl. So product will be same. Product will be always same. Just like. Here water is there, then only we can use H plus, any sulfuric acid. But here acid is present, we have to remove acids. Then only we can use one base. By using one base to remove acid. This is a base. This is all they are asking. Important. What base are used to remove acids from these two reagents? Okay. So product will be same as usual product. You know that. What's the product? CH3, COO, CH2, CH3 plus what? HCl. Write fast. The esterification. Finished? Okay. Finished all this? Okay, right. Okay, next one. Put the common heading, general heading, test to differentiate primary, secondary and tertiary alcohol. Primary, secondary and tertiary alcohol. Test to differentiate primary, secondary and tertiary alcohols. Okay, so here first one, Lucas test. Lucas test. Put the heading Lucas test. Okay. Next one, catalytic dehydrogenation test. Dehydrogenation test. Next one. Steric? Can test what? What is steric ammonium? Is there a? This is for only differentiate. Steric ammonium test, huh?
Steric ammonium nitrate.
Okay. Can test. Short form, can test. If you put the reagent to primary alcohol, what happens? What changes taking place? Sure, okay. We'll discuss it later. Huh? Okay, so here the most important test is what? Lucas test and catalytic dehydrogenation test. So many tests are there. Victor-May test is also there. Victor-May test. This is in matriculation syllabus, state board syllabus. Oxygen test is also there. Okay. Oxygen test. Next one is okay, dehydration. You make it a column. 4 column. So we can complete all the tests at a time. Dehydration test. See that What is glucose reagent? Just listen, after that you can write. What is glucose reagent? It's a mixture of what? Corn HCl and anhydrous what? Zinc chloride. Correct or not? Zinc chloride. In catalytic dehydration test, which one is used? Copper in presence of 573 Kelvin. This only keep in mind. Okay. Oxidation test, we are using one oxidation agent, no? Okay. Suppose we are using PCC, we are using CrO3, we are using KMnO4. Okay, this too is mild oxidation agent. That the role is very important. This is a very important. Okay, PCC means what? Pyridinium chlorochromate. Okay, it converts, what it is doing means it converts any primary alcohol becomes what? What? Aldehyde. It converts any secondary alcohol becomes what? What? Ketone. Understood? It converts any primary alcohol becomes what? Carboxylic acid. Understood? Okay. It's a reagent. Okay. This too is mild oxidation agent. This is called strong oxidation agent. Okay. Then dehydration. What is dehydration? Removal of water molecule. So removal of water molecule by what? Concentrated sulfuric acid, or we can use concentrated phosphoric acid. Okay, these are all dehydrating agent. Okay, this keep in mind. Now see, first one, see, we take primary alcohol. Listen, primary alcohol means here, what is doing means primary alcohol reacts with low-cost reagent, short form writing. Here no turbidity. Turbidity means what? It's a no dirty white precipitate. Second alcohol, if you add low-cost reagent means what? Turbidity. That points only just keep in mind. Turbidity appears between what? Between 5 to 10 minutes. The question will be like this. Dash alcohol gives turbidity between 5 to 10 minutes in presence of low-cost reagent. That is called what? Dash alcohol. Dash alcohol means what? Option A, butane 1-ol. Option B, butane 2-ol. What's the answer? Time is very short. Then only I am giving two options. Butane 2-ol. Dash alcohol gives turbidity between 5 to 10 minutes. What's the answer? Butane? Dash alcohol. Second alcohol, no. So butane 2-ol is the second alcohol. Is the answer. Understood? Are you following? Okay. Then after that, from this, they will proceed the problem. It goes on. Then butane 2-ol, it is oxidized by chromic oxide to form dash this ketone. Understood? Like this reaction going on. Okay, right. Then tertiary alcohol reacts with low-cost reagent. What? Turbidity appears immediately. This is only highly reactive. That appears, just right, appears immediately. Okay. So what is the reactivity trend? Reactivity trend towards low-cost reagent means what? Who is highly reacting? That's right. Write fast. Okay. Write fast. These are the points you should keep in mind. What is low-cost reagent? One question we can expect. These points, all the points you study, okay, then only we can find out which kind of alcohol that is. Okay. Nijra? Okay, right. Then copper 573 means what? What is the meaning for this? D. What is dehydrogenation? Removal of hydrogenation. Removal of what? What is the meaning for this? Removal of H2. Dehydrogenation. If you see copper 573, we have to remove only hydrogen. Understood? Okay. See that this one is very important. See, I finished all this. This one finished, huh? Okay. Okay, right. Okay. Now come to catalytic dehydrogenation test. Catalytic. See, listen, easy one. See that what I am telling here. Primary alcohol, copper 573. What happened? Always gives, aldehyde. Second alcohol, copper 573, always gives ketone. Tertiary alcohols, copper 573 Kelvin, always gives, alkene. This only keep in mind. So based on this, I'll give equation. Say for examples, primary alcohol means what? I'm taking this one, CH3, CH2OH. Understood? Copper 573. What happened? Dehydrogenation means what? Removal of hydrogen. Removal of hydrogen. No. See, listen carefully. One alcohol hydrogen, one alpha hydrogen. That's all. Understood? One alcohol hydrogen, one alpha hydrogen. Alpha hydrogen means this near the hydrogen which is nearer to the OH group. No. Okay. So what? Product will be CH3CHO. Cut off. CH3CHO. So what? Aldehyde. Cut off. Second alcohol means I am taking this compound CH3CHOH CH3. Oh, the same reagent. What happened? One alcohol hydrogen, one alcohol hydrogen, one alpha hydrogen. Understood? So we get the product. I told you, ketone. We are going to get only ketone. So CH3, what? CH3 C double bond O. Cut or not? CH3 C double bond O CH3. Understood? Then if I take tertiary alcohol means what? CH3 OH. Here, is there any alpha hydrogen? Only alkyl hydrogen is present, but no alpha hydrogen. Correct or not? No alpha hydrogen. Then only here, if you use copper 573 Kelvin, only dehydration taking place. Dehydration. Okay. Then only we are getting what? Alkene is obtained. This is only exceptional case. We can take OH from any all are CH3, no? Understood? So the product will be what? CH3 C double bond, isn't it? Correct or not? I'm taking water between these two carbon, no? So here double bond will come between this. Understood? So we get alkene. Right fast. One common they will give on the arrow mark, they will give copper 573. You must know the role of the copper 573. So if you memorize, you can get the answer. Right fast. This 4 test very important. You can get at least one question. This 4 test very important. All the compounds giving, all the kinds of alcohols giving different product. Understood? Aldehyde, ketone, okay, alkene. The problem will be like this. The statement problem. They will be like this. The compounds reacts with copper 573 Kelvin to form ketone, okay, which is the molecular formula like this, the reaction going on. So you must know, okay, copper 573 means you must know this. Finished? Okay, then this also keep in mind. If I then come to the oxidation test. Finished? Okay. Come to oxidation test. What happened? Here, I'll write it here. Right. You take what happened? Primary alcohol means what? CH3, CH2, OH. Simple compounds I am taking. PCC. What's the use of PCC? primary alcohol becomes aldehyde. It's an oxygen agent. It's a mild oxygen agent. Mild oxygen agent means it supply oxygen. So in one alkyl hydrogen, one alpha hydrogen, what happened? One alcohol hydrogen, one alpha hydrogen, one oxygen. H2 will be removed. The product will be CH3 CHO. Correct or not? So product will be CH3 CHO. I told you, primary alcohol gives PCC is, what's the role of PCC means? It converts primary alcohol becomes aldehyde. It's an aldehyde. Understood? Okay. Then likewise, secondary alcohol, how to do. Okay. Chromic oxide, mostly chromic oxide. So what's the product? So this also supply oxygen. So one alcohol hydrogen, one alpha hydrogen. So H2 will be removed. The product will be, CH3, C double bond O, CH3. Understood? Right. Ketone. I told you clearly. This only keep in mind. Then only the chapter will be easy. Among this, who is the powerful oxygen agent? KMNF is a powerful oxygen agent. It converts directly acids into, alcohol into acids. Understood? Right. Third one. Here tertiary I didn't do. Why? Why tertiary will not undergo? Because why tertiary will not undergo? Absence of
lesser number of carbon.
why tertiary alcohol will not undergo oxidation? Because absence of alpha hydrogen. No alpha hydrogen. No. Is there any alpha hydrogen? No. It's supply. Oxygen is there. Alcohol hydrogen is there. No alpha hydrogen. So due to what? Due to absence of, write fast, absence of alpha hydrogen. Write fast. That's the reason. Okay. Understood? Finished? Next one, the last one, dehydration test. This no. Can you follow this one? If you put in ethanol, it becomes ethanoic acid. Propanol means propanoic acid. Okay, mostly it comes from only primary alcohol. Propanol, propan 1-ol, if you put means what happened? It becomes propanoic acid. Butan 1-ol means butanoic acid, KMNO4. Okay, right. This one memorize thoroughly. Okay. Finished all this? Okay. Next one. What is the next one test? Dehydration test. Dehydration means removal of dehydration test. Dehydration test. Okay, you know that removal of simply removal of H2O by using what? Concentrated sulfuric acid, or you can use concentrated phosphoric acid. Okay, understood? See, I am taking all the primary, secondary, tertiary, all the alcohols is going to give what? Only alkene. Last time we are getting we studied catalytic dehydrogenation test. Primary alcohol gives aldehyde, secondary alcohol gives ketone, tertiary alcohol gives alkene. We study but in this case, if all the alcohols undergo dehydration, the product always what? Becomes what? It becomes ketone. Primary alcohols also gives becomes alkene. Alkene. Second alcohol also gives alkene. Just right. Tertiary alcohol also gives alkene. Okay. Put in box. Okay. So primary alcohol, I am taking 1,0 alcohol, CH3CH2 OH. So we put concentrated sulfuric acid at 443 Kelvin. Second alcohol, CH3CHOH. Here also they are using, I think, concentrated phosphoric acid they are taking in your textbook. Here 85%. Here I think textbook 85% is taken. This is called 440 Kelvin. Tertiary alcohol, CH3, OH. Here also concentrated sulfuric acid, phosphoric acid. Both we can take, anyone we can take, but here 20% only taken. The temperature is going on reduce nearly 358 Kelvin. All are is going to get only alkene. All are going to produce only alkene. See what happened? Dehydration process, no. Removal of water, no. So OH from here, don't take alpha hydrogen, beta, always beta. Understood? What? Are you following? And now we are getting what? CH2, double bond, CH2. Correct or not? Plus H2O. Then this OH takes hydrogen from this alpha, no? These two are beta. Both the betas are looking same. We can take any side. But if it different means use what? Shades of rule. Longer chain we can take. Okay, understood? Okay. Now, here also we are getting product is what? CH3, CH, double bond, CH2. Correct or not? Here also all the beta looking same. Correct or not? All the beta looking same. Right. Product, tell me. CH3, C, double bond, CH2, single bond. All are alkene, no? All are alkene. Then I put what? All are alkene. Understood? Which is more reactive means reactive trend. Tertiary. Because at low temperature it reacts, no? Even 20% is given, it is reacting. Then only the trend is what? Trend. Tertiary. Okay. Right past. The reagent role, just memorize, study thoroughly. Otherwise, are you following? Sure. Right. Next one. Finished or not? All this. I will not say very easy, very tough. But the reagents only just keep in mind. Okay. So we are memorizing so many things, terms and all you are memorizing. Okay. The reagents only first memorize what's the role of these reagents. If you know this, you can easily answer. Okay. Sulfuric acid, sodium borohydride, lithium aluminum hydride. Okay. So Lucas reagent, copper 573 Kelvin. Okay. Diborane, H2O in presence of H plus. All the reagents just keep in mind. If you come across so many times, this the same equation means you can use to find out. So this is the reaction. Otherwise you cannot find out. Okay. Simply saying this is out of portion. No one is out of portion. All are in syllabus only. Okay. But same equation you should come across many times. Okay. I come across 200 times, just 200 times only. Yeah. Each year I am come across 10 times. So 20 years I'm you know that. Okay, right. Then okay, if you see this reagent means this, I know this is the role of this reagent. So what it's doing means I know. So this into that. Okay, right. So properties at last I will teach all the properties, general properties. Okay, so right, phenol, right. All the properties I will teach at last clearly. Phenol formula, it's aromatic alcohol, no? What's the formula? OH, understood? It is otherwise is called, carbolic acid. Somewhat weakly acidic character. Then we are using the word carbolic acid. Okay. Then as usual, I told you preparations you already studied. Okay. Once again, I recall all this. That is, first one is prepare from what? What's the process? Dose process, no? Okay, you know that. Okay, dose process. What is dose process? Chlorobenzene. Last class we studied, no, that haloalkane, halogen chapter we studied, no? If you put NaOH, within one step I complete. We cannot remove Cl, no? Because what character? Partial double bond character. sp2 carbon this is. So normal, if you put only NaOH, reaction will not taking place. So what? 623 Kelvin and 300 atmosphere pressure. If you see this reagent, you must know Dow's process. Okay, then only we can remove Cl, then we can substitute OH group. You know that. Okay, we get what? Phenol. This one method. Understood? Second method, from aniline. Aniline is, what is aniline? We studied, no? NH2. So, it undergoes diasterization. Diasterization means what? NaNO2, 2HCl, 273 to 278 Kelvin. You know that. What happens? It converts NH2 into, we studied the amine chapter, no? It converts NH2 into what? N2Cl. Okay, we studied. Then, if you hydrolysis at 283 Kelvin, hydrolysis, if you do hydrolysis, N2 remove, understood? N2 is removed, minus HCl is removed. We have only OH group. That now it is on. Okay, phenol is formed. Third one is very important from, cumene. Cumene is what? It's one of the hydrocarbon. Okay, toluene, we are saying, benzene. Cumene is also one of the hydrocarbon. It is, how it is obtained means it is obtained from benzene. Benzene, this only just listen, after you can write all this. What is this? Benzene plus propane. In presence of, what's the name of the reaction? Anhydrous aluminum chloride. It's a Lewis acid catalyst. Okay, what happened? The middle carbon is going to add here. Middle carbon. Whenever if you want to substitute anything, means we have to replace. Benzene means what? What's the formula? C6. Benzene. C6. Yeah, C6 H6. If you want to add anything, we have to replace hydrogen. Each and every corner we have carbon as well as hydrogen is present, no? Okay, so if you want to add anything, means you have to replace hydrogen. That replaceable hydrogen goes to what? This side. So CH2 becomes what? CH3. Understood? Now double bond becomes automatically single bond, no? This is called cumene. Understood? See? CH single bond. Are you following? This is called cumene. Okay. Then actually in your textbook, they given from this cumene. Okay. Then that oxidized cumene. This is called it's called cumene. So cumene is oxidized. We get what? So simple. Remember, the two oxygen. The two oxygen is going to add in between C and H. Okay. See, this two oxygen is going to add in between C and H. You remember like this. I also remember like this. Okay. Then it's a very big product, very big product, If you want to hydrolyzed, okay, H plus, what happened? This will be one product. What is this? Our aim is to get only phenol, no? OH on benzene ring. Okay. So just write. OH plus what? Here CH3, COCH3. Understood? Acetone is obtained, or ketone, or propanone. Right. It first. These are the method, important method. This and all, they will give this one, they will put question mark here. You must know. Understood? That kind of questions they will ask, I think. Okay.
Cumin often they are asking.
Hmm?
Cumin
Hmm.
often they are asking.
Yes, mostly. Then sometimes the same question they'll ask in different way. What's the molecular formula for this? What's the molecular formula for cumin? Cumin molecular formula. C? C6 ah? C6. Here one 3 carbon ah? C9. That ah? Hydrogen. 1, 2, 3, 4, 5. 5 hydrogen. Here no hydrogen. 5 hydrogen. Here what? 5 plus 3, 8. 9 plus 3, 12. The hydrocarbon C9H12 on oxidized to form, this is called cumin hydroperoxide, okay, which on hydrolysis to get dash, okay, phenol. So this kind of question they will ask in statement, okay. Read fast. The question may be like this. See, C9H12.
In those process, after adding NaOH, they are converting into
Sodium phenoxide.
phenoxide.
So I told you, when I teach, I am writing directly.
If you forget that Kelvin atomic atom, now we can use that.
Yes, yes. But actually, but if you put this temperature in question, means the Cl becomes directly OH. We can write, no problem, no problem. But but suppose you see that, suppose one more A directly, this is A means phenol is the answer. Sometimes A again question mark, again they'll give some reagent, then again B means in between step is what? Sodium phenoxide. Sodium phenoxide, SCl is removed, no? So ONA is obtained. That ONA again SCl is added, OH is obtained.
Without putting the Kelvin, they are asking question mark.
Yes, sometimes.
That means what, sir? That means
Without putting Kelvin means?
without giving that Kelvin or atmosphere directly, only with NaOH they are using.
Only NaOH. Without this one temperature, then reaction will not taking place. But in our book, so ONA is given. Second step only they put reagent. Only is there? Okay. So only NaOH means here, due to partial double bond character, we cannot fully replaced by Cl by OH. Fully replaced by OH, no. Then only they are adding this temperature. In our book, second place temperature or first place temperature?
Sir, if we do with temperature also, we are getting sodium phenoxide only. Then they are using a HCl, then only we are getting phenol.
Then I told you, when I write, I told you, I am writing directly. Say, if you put this, what happened? What is it? We get HCl is removed, so ONA. Then that HCl is removed, no. The HCl is going to react once again. So what? Minus NaCl. So now what? Phenol. That's all. Okay, this is a product. This unless this temperature and pressure, the reaction will not taking place, because aryl halides will not undergo any nucleophilic substitution reactions. Okay. Next, all this understood. One more method is also in a textbook is there. Second method from benzene also. Benzene plus sodium hydroxide. That you go through that one. Simple one. Okay. Understood. These three methods is very important. Okay. Next one, you put the chemical properties. chemical properties of phenol. Okay, right. Here 6 properties, 6 or 7 properties are there. That is, I think this only you studied Cole's reaction. You know what is Cole's reaction? What is Cole's reaction? It converts what? Phenol to what? Salicylic acid. This is all you know, studied. Phenol to salicylic acid. Okay. So you want to write? You studied or not? Phenol to salicylic acid is called Cole's reaction. Okay. Here, what's it? You know, that 400 Kelvin, 4 to 7 atmosphere. Okay. Carbon dioxide. This all is keep in mind. Okay. Raymond reaction. What is Raymond reaction? So if you want means I'll write. Okay. If you want means I'll write OH and tell me. NaOH, what happened? O? H2 will be removed, O and no. Then when we add carbon dioxide, if you see carbon dioxide means you must know. Okay, what is it? It is a Cole's reaction. What happened? The CO2 is added here. We get one hydrogen, no? One hydrogen is there, no? That hydrogen goes here. Becomes what? ONA, COO, plus OH, CONA. Then any acid is added, what happened? Salicylic acid. Okay. So this is called salicylic acid. OH, COOH. Okay. Salicylic acid. It's called, you know. Okay. Salicylic acid. Studied from the textbook. Easily, it's given very clearly. Okay. This only just write. If you want means, just only write. Otherwise, you refer book. You put. No need to write. Okay. Then.
Another short method. They are adding directly phenol plus carbon dioxide. Then a reagent NaOH and HCl they are adding. Directly salicylic acids.
Directly salicylic acid. Phenol plus COH. See carbon dioxide.
Carbon dioxide. Reagent NaOH and HCl.
Okay. Okay. That's all. But this is the best method for. First I am adding NaOH. First they are adding CO2 first of all. Okay. Understood? Cole's reaction means phenol to salicylic acid. This only remember. Okay. Then Raymond reaction. Raymond reaction. What? Phenol to? You know, phenol to what? Salicylaldehyde. Okay. Salicylaldehyde. This reagent only just write chloroform, NaOH. These are all added. We are getting what? Salicylaldehyde. Salicylaldehyde means what? CHO. That's all. This is simply remember. This is called what? Salicylaldehyde. This is called orthohydroxybenzoic acid. This is called orthohydroxybenzaldehyde. Other name. What is this? What is this? Phenol, no? Phenol. Correct or not? What is this? Benzoic. What is this? Benzoic acid, no? Benzoic acid. Okay. Other name for is what? Nearer, no? The two groups are nearer. So what? Orthohydroxy benzoic acid. Orthohydroxy benzoic. Other name also if you want just write. Orthohydroxy benzoic acid. This is called what? Orthohydroxy benzene plus aldehyde. Benzaldehyde, no? So orthohydroxy benzaldehyde. Understood? This is also right. One minute's right. Important one is here, you just write, very important one is in Cole's reaction, CO2 is an, electrophile. Okay, it's a neutral electrophile. Okay, neutral electrophile, but in this case, CHCl2, carbene, is a electrophile. Carbon having one pair of electron will be there. So it's called carbene, we can say. It's called electrophile. What's the electrophile used? Somebody will ask, what is electrophile? Here, but if you have the mechanism, this HCl will be removed. We get CHCl to know. Okay. So that will act as an electrophile here. Understood? Sometimes they'll ask. Okay. These are all only electrophilic substitution reactions. Okay. Next one. Next, this one keep in mind. Phenol to salicylic aldehyde, remetainment, phenol to salicylic acid, Kolb's reaction. Understood? Okay. The reactions, if you want me to go through that. Another one is third one, important. They put electrophilic, here only they put electrophilic substitution reaction. What kind of director? This is phenol is a what kind of director? It's ortho and para directing group. Ortho and para directing group. Keep in mind. Okay, ortho para directing group. So if you do nitration, what happens? If you do nitration, it is getting, we are getting what? Ortho product as well as para. Ortho product as well as para product. Okay. But especially first of all we use dilute HNO3. You want me to write fast. Nitric, just you write HNO3 dilute. Okay. I told this is what? This only you put important sim. We are going to get ortho product as well as orthonitrophenol and paranitrophenol. Here they'll ask some question. Okay. It's called orthonitrophenol. It's called what? Paranitrophenol. That. Here make the difference. Some question they'll ask from this. Read fast. Following. Okay. When it undergoes nitration, we are getting ortho product as well as para product. Understood? So here I am saying this is having what? High boiling point. It's having low boiling point. Here high boiling point due to mostly organic compounds have high boiling point due to what? Reason is hydrogen bonding. Most of the cases the compounds having high boiling point due to hydrogen bonding. Here this compounds having high boiling point, I am saying hydrogen bonding is present between the two molecules. One more molecule I am writing here. High boiling point due to intermolecular hydrogen bonding. What is meaning for intermolecular hydrogen bonding? The hydrogen bonding is present between the two molecules. One more molecule I am writing here. So what? What is hydrogen bonding? Hydrogen is bonded between hydrogen of this molecule, oxygen of the inter competition, intra competition. Inter competition means what? Inter means between the two schools. The competition takes place between the two schools is called inter. The competition takes place within the school means what? Intra. Okay. So here the hydrogen bonding is present between the two molecules. So it's called what? So all the molecules are bonded by hydrogen bonding. So if you want to boil means we have to break all the bond. Then only it will boil. So when compared to intra and intermolecular hydrogen bonding is more stronger. So that high boiling point due to intermolecular hydrogen bonding. This is what? Tell me. Due to what? See here hydrogen bonding is present. See within the molecule. No? Within. H of here, O of here. Understood? Within. So due to what? Intra. Understood? It's called what? Intramolecular hydrogen bonding. Understood? Right. Like so many points are there, right, one by one. Be quick. High boiling point, no. So what? Less volatile. Can you say like this? Do not boil, so less volatile. This is more volatile. Understood? More volatile. Okay. Less volatile, more volatile. That's right. Who is more acidic means I am saying this is more acidic. So mostly para position only more tendency to withdraw the electron. Okay. What is acidic? It is only giving H plus ion very easily. Okay. So it is more acidic. It's what? Less. That's very important, this point. Okay, they will give the which is more acidic, they will give. Like, okay. Very important points. All this studied thoroughly. Then they have different boiling point, no? Can you then how will you separate these two components means what? Separated by what? Separated by steam distillation. Steam distillation, right? All the points important. Separated by steam distillation. Okay. Then what's isomerism beginning? What kind of isomerism? Position, functional, chain. Position only different, no? Ortho, para. So what's isomerism beginning? They're all what? Position isomerism. Just right. Position isomerism. So these are the important points. Just remember. First 3 points is very important. First and especially first and third, very important. First and third. Okay. Right. Understood? Then, if you do dilute nitric acid, then only we are getting this product. But if you use this A, if you use concentrated nitric acid, what's the product? Tell me. Phenol gives? Phenol gives what? Picric acid, no? Concentrated nitric acid. If you use concentrated nitric acid in presence of concentrated sulfuric acid, we get picric acid. Picric acid means it is more acidic. Then only they are saying what? Picric acid. Ortho, para, again ortho. All the ortho and para position we put NO2. So it pulls all the it makes the OH bond weak. More tendency withdraw, no? It's electron withdrawing group. So H plus is easily going. So this is called what? More acidic. So what? Picric acid. Right fast. Are you following? Dilute means we get ortho and para. Constant means we get what? Picric acid or 2,4,6-trinitrophenol. Sometimes you can say 2,4,6-trinitrophenol. Okay. Understood? Just like that, bromination. Same. If you put bromine, we get ortho and para. If you put bromine water, we get all the bromine in same benzene, phenol compounds. Okay. Right fast. Finished up? Sure. What kind of director? Ortho and para direct. This only keep in mind. Then after that you can proceed the properties. Okay. So without know this, don't proceed. Otherwise, no use at all. It is a ortho and para directing group. Whatever if you add, we are getting ortho and para product. Understood? Okay. Just like halogenation. Simple, same thing. So all the points you keep in mind. Very important. Okay. Which one is more acidic, which one is less acidic, which one having high boiling point, which one is more volatile. So first 3 points, okay, all very important. Then next one, nitration, first one. Second one, halogenation, right fast. Halogenation, same we did know dilute nitric acid, corn nitric acid, no. Likewise here OH, bromine in presence of carbon disulfide or chloroform, okay, or you can use, I think, carbon tetrachloride, anything you can use. We are getting ortho and para product. You write yourself. Suppose here same phenol when it interacts with bromine water only we are getting what? 2,4 tribromo 2,4,6 tribromo phenol. This is actually, it's a white precipitate. Then only we can say this reaction is called what? Test for phenol. You can say it's called test for phenol. Write first. This one you write yourself. What's the product? Orthobromophenol, you don't know. Para, this it's an ortho product as well as para product. Understood? OH, we have ortho, at the same time we have para. This one no. Mostly para is the most stable, major product also, you know that. Okay, right. This reaction is called test for phenol. Okay, one more test I will write. Or you put separate heading, test for phenol. Test for phenol means, phenol gives white precipitate. Just write white precipitate. Phenol gives, just write white precipitate with bromine water. This one point. Okay. Second point, phenol gives violet color with what? Neutral ferric chloride. Neutral ferric chloride. Okay. This and all where it is using means we will ask to find out what's a chemical test to differentiate. What's a chemical test to differentiate these two compound? What is this? What is this? Phenol. What is this? This is phenol. This is called cyclohexanol. This is phenol. This is called what? Cyclohexanol. Understand? Are you following? Okay. So phenol only can answer these two. Cyclohexanol will not answer. Are you following? Okay. Right. Right fast. Next, all this. We started 1 hour late today. Otherwise, I complete. Next, test for phenol. This point important. So only they will give what is how will you test these two common means phenol answer this one cyclohexanol will not answer. Okay. Cyclohexanol, so phenol gives white precipitate with bromine water, but cyclohexanol will not. Okay, right. Write all the points. Okay. Then only two points. Oxidation reduction. Another one is oxidation, then reduction. Phenol is oxidized. What? This is a very standard question. Phenol is oxidized by potassium diachromate K2Cr2O7 in place of H plus. You just study. What is this here? It's oxygen. No. Here inside we have what? 3 bond.
Sir, in book they gave instead of potassium sodium.
Instead of
Potassium they gave sodium.
sodium dichromate. It's okay. Anyone we can use. No. All are oxygen only. Not a major mistake. This and all. Okay. It oxidizes Phenol to what? Like this. Just remember. Inside the bond will be rearranged. We are getting a para benzoquinone. Just this will all keep in mind. Very standard question. Phenol is oxidized to get dash. Okay, para benzoquinone. It looks like quinol, no? You know what is quinol? Quinol is a quinol. And commercial name for that quinol. It, you know, diol, aromatic diol. Okay, you know, qui. C double bond O, no? C double bond O means ketone, no? So qui plus ketone, quinone. Para benzo, no, two are opposite, no, para benzoquinone. Or simply we can say benzoquinone. Just phenol oxidized, we get this compound. Then phenol is reduced. Tell me. Phenol is reduced. Phenol is reduced in presence of, you know, nickel in presence of H2. What? Phenol is reduced. What is it? We studied, no, 11th standard we studied, no? What happened? What's the product? If you want to convert one double bond into single bond, we use 1H2, no? Yeah, so what's the product? CH3, single bond, CH3, no? But here, 3 double bond, so what? Don't worry about the 3. If it undergo reduction, so inside no bond will be there. So what? Cyclohexanol. Understood? No bond will be there. Understood? Okay. Then one more reaction with the zinc, very important. Phenol, you know that we studied. What is the product? Tell me. Benzene only we get. Understood? Zinc oxide will be removed. Okay, so product will be what? Only benzene, right? These are the importance about, you know, phenol plus Z and O. Okay, right. Next. Understood? Okay. Phenol is oxidized, phenol is reduced, phenol reacts with zinc. This is all we study as it is. No change of product, no. Product will be as it is. Okay. Very simple. Ethers, I'll complete fast. Ethers. Formula is RO R dash. It's a formula. Okay. Try to understand. Try to understand the situation as well as syllabus as well as timing. Okay. What's the formula? RO R dash. Simple one. Very simple. You know, around the oxygen atom only we have alkyl group. Alkyl group, or it may be aryl group. Okay, understood? So simple, you know, instead of R I put what? Both the sides I put same means it's called what? What ether? Symmetrical ether. Both the sides I put same group. Okay. So CH3, CH2, CH2, CH3. Correct or not? Both the sides I put same group means called symmetrical ether. Both the sides I put different group means called what? Unsymmetrical ether. One side I put CH3, another side I put what? CH2, CH3. Understood? One side I put CH3, another side I put C6H5. Okay, right. Now tell me, what's the IPS name? Simple one. Need not write, just listen. Okay, both the sides same group, no. So you take oxygen, methyl plus oxygen, methoxy, then remaining one carbon, no. So what? Methane, methoxy, methane. This is what? Both the sides same group, no. We can take ethyl plus oxygen, ethoxy, ethane. Understand? No doubt. But when you come to unsymmetrical ether, you have to split. You take oxygen along with smaller alkyl group. It's a rule. Smaller. It's a smaller, no. It's a bigger, no? So smaller only we should take. Understood? What? Tell me. Methyl plus oxygen? Methoxy. Methoxy. Remaining how many carbon? 2 carbon. No. So what? Ethane. Here, methoxy. Methoxy. Benzene. Don't say phenyl. Okay. So methyl plus oxygen. Methoxy. Benzene. Understood? Okay. This only we have one commercial name. What is this? This is called what? What? Anisole. Suppose CH to one side ethyl group is present means called phenitol. One commercial name. Now you know the name. What's the name? What's the name? Ethoxy benzene. Understood? Are you following? Ethoxy, as usual, benzene. This one commercial name is called phenitol. That's called anisole. I told you, no? It's called phenitol. Just remember. Okay. So these are the important things about, classification of ethers. Okay. If you want means write. Otherwise, everything is given. It's clearly in the textbook. How unsimplic ether is very important. How we can give the name. Okay. Tell me this. Tell me. Who is smaller? CH3. So no doubt. Okay. Now this is a parent hydrocarbon. It's a parent hydrocarbon. Take the longest carbon chain 1, 2, 3. The longest carbon chain. No. Okay. So 2 having methoxy group. 2 having 1, 2, 3. Yeah. 2, 3. 1, 2, 3 means what? Propane. 2 having what? Methoxy group. So 2 methoxy propane. Are you following? Okay. Just 1 or 2 commons. 1 means right. Understood? Right. Are you following? One IPS name they'll ask. Okay. So among 50 questions, no. One questions they are asking. They will give the structure. You have to give the name for that, especially IPS name. Okay. Among the we have how many chapters? We have 6 chapters. 11 standard, 2 chapter. 12 standard, 4 chapter. So among these chapters, they will ask one common. Okay. Understood? Okay. Preparation, very simple, only 2 methods is get there. Preparations of ether. Okay. So first method is very, very important. Williamson ether synthesis. So condition and all you just keep in mind. What's a principle behind means? It's a SN2 reaction. Okay, SN2 reaction. We should take what? RONA plus RX. We get what? Just listen carefully. RONA means any alkoxide, no? Alkoxide. Sodium alkoxide. Okay, one base we should take. This is alkyl halides. No, this is very, very important. Primary alkyl halide only we should take. Primary alkyl halide. Very, very important. Then only we are getting what? Ether. Understood? Primary alkyl halides. Compulsory we should take only primary alkyl halides only we should take. Okay? Right. What's the product? Tell me the product. RO or plus what? If you put dash means you put dash NaX. Correct or not? Okay? This is a condition, ma. Primary alkyl halides only we should take, then only we get what? Ether. Suppose here I'll take CH3I. C2H5ONA. What's the product? Tell me. C2H5O. C2H5O. CH3 plus what? I. Okay. You see, when I give equation, you see the alkyl halides. Just focus on alkyl halides only. Whether it is primary or secondary or tertiary. What is this? What kind of alkyl halides? Primary, no doubt. Primary means only what? We are going to get only ether. This point is very, very important. This is very, very important. Understood? Okay, now we can get ethers. So, what kind of ether? Tell me. CS3, C, CS3, CS3, O, C is correct or not? Correct or not? Okay, right, you know. Name and all, you know. Smaller group, no? Methoxy. 1, 2, 3. Methoxy. 2-methoxy, 2-methyl propane. Can you say like this? It's the longest carbon chain. 2-methoxy, 2-methyl propane. Understood? Okay. Suppose the same equation, just look at the same equation. If I write like this, here tertiary. Listen carefully. This one important. Now tell me. We are not getting ether. What is it? Because of what is this? What is this? What kind of alkyl halides? It's a tertiary alkyl halides. No, are you following? Okay. I told you, primary only can give ethers, but tertiary we are not getting ether. But if you take means, we are instead of ether we are getting only no ether compound, but what? Alkene is obtained. Just note down. It's very important. No ether is obtained, but alkene is obtained. Okay. Alkene, what kind of alkene? Tell me. As usual, NAI is removed plus the CH3O, no? The CH3O takes one hydrogen from here, any one hydrogen. Okay, so it becomes, just try to understand. NAI is removed, okay, this, try to understand. Okay, CH3OH, no? Okay, right. Okay, CH3OH, CH3OH plus, NAI is removed, and here the double bond will come, no? So I told you, no, if you take tertiary alkyl halides, no ether but alkene is obtained, I told you. Okay, so here elimination reaction is domination with nucleophilic addition reactions. Okay, nucleophilic substitution reaction. If you take tertiary alkyl halides, elimination reaction is dominant. Okay, that only keep in mind. The product will be what? CH3, C double bond, CH2 single bond, CH3. Understood? Are you following? Okay. If you take primary, then only we are getting ethers. Okay. All this equation right. One more thing, you write C6H5ONA plus CH3I. You know that. What's the product? Is it primary? No? No doubt. Primary alkyl, that's also important. It's anisole. So we get the product anisole, no, OCH3 plus NaI. This is called anisole. Understood? Right, this also note down. We know means leave it. But these two, everyone should write. These two equations are very, very important. Just everyone should write. Then only we can able to differentiate. This is primary, then only we are getting ethers. This is tertiary, we will not get ether. Okay? Understood? Finished? Any doubt? Only two equations I complete. Finished? Huh? So Williamson is very important now. Okay. Williamson SN2 based on SN2 one condition. Another one is primary alkylates is you should take. Then we are getting ethers. If you take tertiary means we are getting mostly an alkene is obtained. Okay. one method we finished now. Second method is from, simple, we studied already, from alcohol. From alcohol also, you know, CH3CH2OH. They will simply put like this, 413 Kelvin concentrated sulfuric acid. What is this? The same thing, you should write 440 or 443 Kelvin. Okay, no change. Okay, concentrated sulfuric acid. This is called what? Both the cases, 413 Kelvin means, you just remember, it is called what? Intermolecular dehydration. So what's the meaning for intermolecular dehydration? Water is removed between the two molecules. Correct or not? Then only they will not give 2 times. You must know 413 means intermolecular. Intermolecular, we should write what? 2 times this one. Are you following? You must know. They won't give 2 times. Okay. So what? So what we are getting? Ether, no? CH3, CH2O, ethoxyethane. Okay. CH3, CH2, CH2. Correct or not? Ethoxyethane. Suppose this is called what? 440 na? Intramolecular. It's very important. Intramolecular dehydration. Intramolecular na, within one molecule, what is eliminated? Within one molecule. See, within one molecule na, here, simple. Within one molecule of ethanol, water is eliminated. Okay. Product will be what? Very important. CH2 double bond, CH2. Okay. Understand? The same compounds undergo this temperature, we are getting different product. Okay. Just note down fast. Only 5 minutes, I'll complete. This reaction I have given, the problem solving session I have given. When it goes this way, we get product A. When it goes this way, product B. So what is A and B? I asked. Okay, see the problem solving sessions, I have given this kind of questions. Okay. Same compound, but the reagents differ, the factors differ, product also differ. Okay. Same students, if we come here, you'll be getting some marks. The same students, if they are studying in our own, they won't get very high marks. The same students, okay. So, if they go to any coaching center, somewhat, they know something, okay, different. Okay, understood. Likewise, same compounds undergo this method, this way we get that product, this way we get this product. Okay, understood? Can you follow? What is this? Inter, between. Okay, right. Understand the concept? Only 2 equations I'll complete. Just 5 minutes I'll complete. Chemical properties is very, very important. Okay, see, first one, with these conditions, just all of you write in your note. Very, very important. Reaction with HI. See, the 3 conditions we should follow. The iodine prefers, iodine prefer, not generally I put iodine, but any halogens, iodine prefer smaller alkyl group, if both are primary. If, all of you write, if both are, it's not in textbook, my own notes, iodine prefer smaller alkyl group if both are primary carbon. What's the meaning for this? Suppose here, example, CH3, CH2, CH2, O, CH3. If you add HI, what happened? Iodine prefer smaller alkyl group. Smaller means what? I told you, CH3 is also primary, CH2 is also primary. Just remember, CH is secondary, C is what? Tertiary. This one keep in mind. Usually we remember only CH3 only primary, but CH2 is also primary. See here, this is primary carbon, this is also what? Primary carbon. Understood? So both, I told you clearly, iodine prefers smaller alkyl group if both are primary. So smaller means where it goes? Iodine, I here, H here. Understood? Product will be what? Product will be, all of you write, very important, CH3CH2, OH plus what? CH3I. This one. Okay, another rule, iodine prefer, just write fast. Don't wait for me. Iodine prefer sp3 carbon. One more thing, iodine prefer tertiary carbon. Iodine prefer tertiary carbon. That's the rule. So here, last time both are primary, then only I prefer only smaller. Now, what kind of carbon? Understood? O in the middle, no. This side, this side. This is what carbon? Primary. This is what carbon? This is called tertiary carbon. Okay, this is a rule. So iodine prefers, I told you, no, prefer tertiary carbon. So what? The product will be what? The bond is broken. I here, H there. Okay. Are you following? I here, H there. Okay, product will be CH3, C, CH3, CH3, I plus CH3, OH. Okay. Third rule, write fast. Third rule, iodine prefer sp3 carbon. This is another rule. Okay, see that? Very important. They'll ask in complete the following. Okay. Now, you see that carbon? What kind of carbon this is? This is what kind of carbon? Primary. Now, primary, but you know, it's a aromatic ring is there, no? Then it's called what? What kind of carbon? sp2 carbon. This is called what? sp3 carbon. Understood? Aliphatic is called, you know, sp3 carbon. So what? So I told you, know, I don't prefer sp3 carbon. So I goes here, H goes other side. The product will be what? We get phenol plus CH3I. So these three rules, keep in mind, very important. Understood? Then I put one point here. If both are primary, so yes, second rule will be somewhat confused. Finished? Written all this? This one, finished done? Okay. Then only two properties done. This is one properties. Another properties, you know, it's electrophilic substitution reaction means before studying the electrophilic substitution reaction, you know, what is that? It is a what kind of director? You must know. It is a anisole is a ortho and para directing group. Para directing group. That's all. Anisole is a ortho and para directing group. Then you know all this nitration. What happened? You don't know. While doing nitration, we get what? Electrophilic substitution. You just study what kind of directing group. This only just remember. Others are you can easily study. When you do nitration, what happened? Orthonitronizole, paranitronizole. You know that, yeah. Okay. This is called stable product. Now you know that, yeah. Para only is the most stable product. So likewise, you study other properties also. Chlorination means here also chlorination, chlorine. Okay. Alkylation means here also alkyl group, here also alkyl group. Acylation means here also acyl group, here also acyl group. Okay, understood? It's there. Are you following? Right. Just go through this one, okay? First preparation properties, okay, then go through, then after that go through the MCQ, you can get. Okay, ma. Next class we will see next. The remaining 1 or 2 minutes I will teach in the at last I will teach the properties and all. I will give the notes to you, but you can able to study. Okay, we have properties will be what? Only the boiling point property. Boiling point means when you increase the carbon, boiling point also what? Pentan 2 all, butane sorry, pentan 1 all, butane 1 all. Who is having high boiling point? Pentan 1 all, butane 1 all. Pentan 1 all. Pentan means 5 carbon. Butane means what? 4 carbon. So when the number of carbon increase means, boiling point also increases. Understood? So likewise some acidic property, okay, some general properties will be there. That one I will give the notes. You can able to understand. Okay? Sure. Okay. Next class we will see the next lesson. Okay, I think one of the lessons in physical chemistry, I think. Okay, maybe electrochemistry. Okay, right. Okay, ma. Thank you, students. Any doubt means ask me. Okay. See you.